हेलो आयुषी बरनवाल।
नॉइस ज़्यादा नहीं होना चाहिए, ठीक है। नॉइस के सिस्टम समझ लिया है।
सर स्टार्ट कर दीजिए.
It is time for us to begin with the inaugural session. Unity marks the start, collaboration drives progress, and teamwork leads to success. At long last, the moment we have all been waiting for, the change to engage and learn something valuable is here. Good morning everyone present here. I, Ayushi Baranwal, on behalf of MNNIT Allahabad, is delighted to offer a sincere welcome to all the honorable guests, dignitaries and participants gathered here for the inaugural session of 2-week GIAN Course on Generative AI for Digital Transformation, jointly organized by Department of Electronics Engineering and School of Management Studies, MNNIT Allahabad. This program is designed to provide a deep understanding of generative AI technologies, their implication and practical application. This program has been carefully designed to not only provide you with essential theoretical knowledge, but also equip you with hands-on real-world skills that you can immediately apply in your own professional environment. This program serves as a platform for us to come together, share knowledge and collaborate towards building a more resilient and inclusive future. I am truly inspired to see such a diverse group of participants representing various domains and backgrounds, all united by a common goal to drive positive change. Before starting program, I would like to welcome our honorable guest, Professor Prabhat Vaish, Professor at Computer Science Department, New Jersey Institute of Technology, USA, Professor Rajeev Tripathi, Vice Chancellor at Rajiv Gandhi Pradyaugiki Vishwavidyalaya, the State Technological University of Madhya Pradesh, Professor V.S. Tripathi, Head of Department of Electronics and Communication Engineering, MNNIT Allahabad, Professor Tanuj Nandan, Head of School of Management Studies, MNNIT Allahabad. Light is considered as a symbol of purity, auspiciousness, joy and prosperity, since it dispels both internal and external darkness. May I now request all the dignitaries to join for the lighting of lamp and inaugurate the function. We all bow to Ma Saraswati, may she have her blessings upon us. May I now request all the dignitaries to join for... I would like to extend a warm invitation to our distinguished guest. I request Professor Prabhat Vaish, Professor Rajeev Tripathi, Professor V.S. Tripathi, Professor Tanuj Nandan and Professor G.P. Sahu to kindly take your respective seats on the dais. I now invite Professor Rajeev Tripathi to come forward and present the flower bouquet to Professor Prabhat Vaish. Professor Tanuj Nandan, please hand over a flower bouquet to Professor Rajeev Tripathi. Professor G.P. Sahu, please hand over a flower bouquet to Professor V.S. Tripathi. Professor G.P. Sahu, please hand over a flower bouquet to Professor Tanuj Nandan. As we commence our journey into the realms of knowledge and technology innovation, it is my distinct honor to introduce the co-coordinator and local coordinator of this GIAN course. Professor G.P. Sahu holds the position of professor at School of Management Studies, MNNIT, Allahabad. Sir has completed his PG from MNNIT, Allahabad and PhD from IIT Delhi and also awarded PDF in 2015 from California State University, USA. He is also a local GIAN coordinator since 2015 and coordinator of National Resources Center SWAM since 2017. He has various publications in reputed national as well as international journals. He is having teaching experience of more than 26 years and have active association with different societies and received several awards for his contribution to scientific community. His current area of expertise include management information system, e-governance, information system and information technology planning, e-business, digital marketing, supply chain management, relationship marketing and green IT. I now invite Professor G.P. Sahu to introduce the program and tell something about GIAN initiative as you are a local coordinator of GIAN.
Good morning, all present here. Thank you very much, Ayushi, for your introduction and coordinating this activity. I'm very happy to see the full house here. Okay, so initially we are thinking that maybe during winter season people may not get interested to join such program in face-to-face mode. Nowadays people are happy with online. Okay, so I am here with a dual role that she has already introduced, that I am also co-coordinator of this program and local GIAN coordinator. So all the activities related to GIAN activity in the institute, I take care of it. Dignitaries on the dais, Professor Rajeev Tripathi sir, Professor Prabhat, Vaish sir, and Professor Vaish Tripathi, head electronics, and Professor Tanuj Nandan, all present here, my distinguished colleagues present here. Good morning to all of you. I'll briefly tell you about the GIAN initiative. So as the name suggests that it is a global initiative of academic network. So academic is a keyword here and network is another keyword, that we need to network with the foreign faculty, foreign institutions for development of academic activity. So initial mandate given by the GIAN was to organize programs in the emerging area where we have less number of faculty in the emerging area. So we need to develop faculty and resources, especially focusing on the MTech student and PhD student also. So therefore there is no restriction that student, faculty, research student, all of us will be able to attend such kind of program. Government of India is investing lot of money, huge amount of money being going into this area, and it is considered to be very, very successful program because we started in 2015 and that point onward we are doing it. So if you consider that number of programs being organized, so it is 2,163 number of programs already approved, and then completed one is 1,800 around 50, and there are pipeline. Okay, so huge number of programs already in the pipeline, so around 100 number of already approved programs are there. So and then institution, there are number of countries participating into it, number of institution, 200 number of institution in our country. It is participating. For each program we get a good amount of money from Government of India to take care of the travel expenses and remuneration for the foreign expert, and then local expenses taking place. So it's a very, very important program. That is what I wanted to present before you. So along with, of course, GIAN is academic network. Similar to GIAN, there is another program that is a Spark program where we talk about research network. So research network and academic network, they go side by side, but the purpose is that we need to network with the foreign faculty, foreign experts for developing our academic ecosystem and then research ecosystem. So that's the objective. Other objectives are mentioned here. I'll not take much time because we have started a little late. So broad area of interest. So these are the not only engineering but humanities, social science, legal, management, all areas are included into it. So I consider many of you are faculty, colleagues, those who are participating in this program. Please take interest into it, and then maybe you'll also be able to host such program with the help of foreign faculty in your network. Okay, so this is the list of programs. So I'm also very happy to share that we in the institute we have organized around 43 number of programs we have already organized. So that's a good number. I consider among the NITs we are doing good. So that's the list of programs we have already organized, conducted, and this is about GIAN and MNNIT. All of you are participating in this institute. I must mention that MNNIT is a old institute we established in 1961, and then this we have already celebrated this Diamond Jubilee. And the MNNIT Institute has 14 academic departments. The list of departments are mentioned here. Few of the pictures I'm showing, all of you will get an opportunity to visit all these places. And then 2 departments are involved into it, electronics and management. HODs, respective HODs are also present. Feel free to visit the department, see the facilities present here, laboratory, etc. I welcome all the participants present here. I'm happy to share that 75 of you have taken interest into this program, and then this goes like that. Faculty colleagues, 2 of you are faculty colleague, industry professional 1, then senior research fellow 1, PhD scholar in majority, that is 45, and then PG student 4. UG student 22 number of UG student you have also taken interest into it. Okay, so these are the number of institutions from where we have received participation. So starting with Institute of Infrastructure Technology Research, then Banasthali Vidyapet, then our own institute MNNIT, IIT Patna, University of Lucknow, Institute of Engineering and Rural Technology, Prayagraj. So list is long. I'm not going to go into detail, but distance places also people are participating in this program. The state represented in this among the participants we received from Arunachal Pradesh, Bihar, Gujarat, Madhya Pradesh, Rajasthan, Uttar Pradesh. So that's a good representation of the Pan-India program. So we have experts. Will be going through the lectures by Professor Prabhat Vaish. He is a professor with New Jersey Institute of Technology. We'll also get lectures from Professor Rajeev Tripathi, who is expert in the area of course, communication, but he will share his experience related to artificial intelligence and introduction to artificial intelligence. I'll also be engaging. I'm Professor G.P. Sahu. I'll also be engaging few of the courses, few of the classes, especially case studies related to artificial intelligence. Pedagogy here is important that we are going to go with face-to-face. Of course, there are many participants who are listening but to this live streaming, but this is going to be one-way communication. They'll not get an opportunity to ask question. Of course, in case they send us email, we'll be able to respond to them. But this class is primarily, it is a face-to-face classroom physical mode, and then learning management system that Google Classroom, majority of you might have joined the Google Classroom there. That Google Classroom, we are going to make use of Google Classroom for sharing the slides, teaching learning material, assignments, and then quizzes. Okay. So quiz organization will also be there. Attendance is very, very important here, that 90% more than 90% attendance is required to get a certificate or participation acknowledgement for the participation. So in this program, as you can see, that evaluation will be there, some quiz will be organized at the end, and in between also in a continuous evaluation process will give you, I'm talking to participant, will give you some assignment, some presentation may also be there, case study, group discussion, etc. So based on those things also evaluation will be there, and based on the evaluation all participants will get a certificate, mark sheet as well. Okay, so mark sheet will be having 2 credit weightage will be given, and this is based on the Government of India's mandate. It will be it is good for technology transfer as well. So later on, if you want to transfer not technology, credit transfer. Okay, so credit transfer can also be done with the this mark sheet. Okay, and then mark sheet will have these are the grades. Okay, so you need to be careful to secure good marks to get a 10 out of 10 grade. Okay, this kind of certificate we are going to give you. I'm very lucky and then very happy to share that I'm supported with a good, very enthusiastic team of students. All of them are my PhD students. They are supporting, and then majority of you have received emails also. So this time, some outsourcing has gone to the student. That students are taking care of the management of the email as well. So I'm thankful to Darshan, Ankita, Akansha, then Vikas is here, Gitanjali, Nasra, all IUC, then Saurabh. All of them are doing excellent work. This is the link. We will be happy to share with you as well, that in case if a few of the friends could not participate in physical mode, you can share with them that such program is available. Live streaming of the program is available. Right now it is also live streamed. Okay. Thank you very much, and wish you happy learning. Thank you. Go to the first slide.
Thank you, sir, for sharing your insight that will definitely guide us for our upcoming discussion. I would like to extend a warm invitation to Professor Tanuj Nandan. Sir is Professor and Head School of Management Studies, MNNIT, Allahabad. Sir had completed his Bachelor of Science, MBA in Financial Management and PhD. His area of research are financial derivatives, investment analysis, risk management and investor behavior. Sir is also a member at American Finance Association. I cordially invite to Professor Tanuj Nandan to grace us with his word and introduce School of Management Studies Department of MNNIT, Allahabad, and enlighten us with his perspective.
Good morning, respected Professor Rajeev Tripathi sir, our esteemed resource person Professor Prabhat Vaish, Head of Electronics and Communication Engineering Department Professor Vaish Tripathi, my faculty colleague Professor G.P. Sahu, who is also the local GIAN coordinator, esteemed faculty colleagues and participants. It's a pleasure to be here. Nice to see that this program is being organized. And like Ayushi said, she requested me to firstly introduce the School of Management. So we are a part of MNNIT, and this department, which is the School of Management Studies, came into existence in 1996. We primarily have a full-time MBA program. We also offer a part-time MBA program, both have 2-year programs, and then we have a PhD program. So we have currently 28 batches which have graduated from the MBA program. So we have been in existence for a decent amount of time, and our students are well placed. We offer certain unique characteristics or unique benefits in the MBA program, one of which is the benefit of doing a dual specialization, a dual major. So we have 5 major areas from which students who are interested can choose, and they go on and do their MBAs. And I'm also happy to share that the PhDs from our department are doing really well. It's a very popular PhD program. We have currently around 48 students who are currently enrolled in our PhD program, and more than 65 students have already been awarded their PhD degrees. As far as this area of artificial intelligence is concerned, I have also been following it with a lot of interest, not just generative AI, but AI as a whole. And if you follow the way this has developed, this aspect of artificial intelligence, when I first started learning about computers long back, we were taught about self-thinking computers and artificial intelligence, and now we are at a stage where we can think of it as the culmination of that effort, or at least the fructification of that effort, because we have seen that technology develops very fast. There is something called Moore's law, which talks generically about the pace at which technology grows. And we say today that Moore's law, which was initially propounded by Gordon Moore, and it was supposed to be true for 10 years, has actually stood the test of time for about 60 years now. So the fact that technology grows very fast is evidenced by the development of autonomous vehicles, self-driving vehicles, which is one of the areas of application of AI. And I was reading a book. It's a very interesting book. If you're interested, its name is simply Autonomy, on how this the development of self-driving or autonomous vehicles took place. It just showcases how technology tends to leapfrog. It tends to move forward in leaps and bounds. So till about the beginning of this millennium, 2003, 2004, the development of autonomous vehicles was going along at a relatively slow pace till this agency called DARPA, which is the research, Defense Research Projects Administration of USA, it announced a challenge, which was that within 2 years, specific distance to be covered autonomously by a vehicle, the challenge was to be completed in 2 years. So the first challenge happened sometime in 2005 or 2006. But what I'm trying to say is that the learning experience from that was that initially in those 2 years, various companies, including research institutions, automobile companies, they managed to develop vehicles, and in that year, not a single vehicle managed to finish that challenge. But it was again held the next year, and people had learned from the mistakes they had made during the first challenge, and they managed to come up with actually working vehicles, and a large number of vehicles were able to complete that challenge within a span of 1 more year. So once the challenge is posed before us, we are able to come up with the solutions. And this is what happens with technology, and AI is really an interesting field. It's a very exciting area, and we are just at the beginning. So there's a long way to go. So I hope you have a fruitful learning experience. There's a lot to be learned here, and I wish you all the best. Thank you.
Thank you, sir, for your invaluable presence and words of wisdom. Again, I would like to extend a warm invitation to Professor V.S. Tripathi. Professor Tripathi is currently serving as a head of Department of Electronics and Communication Engineering at MNNIT Allahabad. Sir had completed B.Tech and M.Tech in Electronics and Communication and PhD from Motilal Nehru National Institute of Technology, Allahabad in 2007. Now, I cordially invite Professor V.S. Tripathi to grace us with his words and to introduce Electronic and Communication Department of MNNIT Allahabad and enlighten us with his perspective.
Thank you, Vaish. Honorable Vice Chancellor of RGPV, Professor Rajeev Tripathi, Professor Prabhat Vaish, Professor Tanuj Nandan, Professor G.P. Sahu, Head Mechanical, faculty members and participants. I welcome you all in this GIAN Course Inaugural session on Generative AI for Digital Transformation. The basic purpose of this type of GIAN courses is to augment the academic ecosystem. Our syllabuses are slightly lagging behind the current technological scenario globally. So that's why Government of India has started this type of initiative to have interaction with international faculty for knowledge enhancement firsthand. We can get this type of knowledge from different platforms also, but the face-to-face interaction with some faculty member who is working in that domain is very impactful. Particularly for emerging areas, we have to go through this type of networking sessions, this type of interactive sessions, and this generative AI, this topic is one of the recent topics which is emerging very fast. I IEEE spectrum, I read an article which says that about 200 CEOs were interviewed by the IEEE spectrum volunteers, and 54% of them remarked that AI is future. And then this term, generative AI, which includes a massive level of data, massive level of data processing for certain applications, for certain automation. This requires two different type of technological developments. One in terms of circuits and systems to support that massive data. The other is to process this data. We need higher level of algorithms. So computer science department, electronics engineering department, they all come in that domain of providing systems and circuits for operation of AI systems. And then there is another challenge, how these AI systems can be used for different applications. And here comes all other departments, all other branches of knowledge. So that justifies that this particular GIAN course is useful for diverse participants. I again suggest all the participants to focus on their purpose. Thank you.
Thank you, sir, for your enlightening words. Now, it's my pleasure to introduce our international expert, Professor Prabhat Vaish, Professor of Practice Informatics at New Jersey Institute of Technology, USA. He is a Senior Technology Executive, Innovation and Business Change Champion with a demonstrated track record of developing disruptive technologies, implementing emerging IT solutions, and optimizing the use of legacy systems to create a competitive market advantage, expand capabilities, and strengthen governance, risk, and compliance. He is a global technology strategy leader with extensive experience in the development of financial services risk and trading products. He is a strong consensus builder with a deep business understanding and extensive IT product knowledge. His key strengths are strategic planning, global team leadership, governance, project management, FX, rates, equity and credit derivatives, trading and risk system, Basel II, SOX, DFA, CCAR, cloud computing, big data analytics, machine learning, product development, Java, Python, R, TensorFlow, and related areas. We will get to know more about him in our upcoming session. Now, I invite Professor Prabhat Vaish, sir, to come on the stage and share your thought with us.
Welcome everyone. You'll be listening from me for next 10 days anyway, including today. So I thank Professor Nandan here, Rajeev Tripathi, old friend obviously, Professor V.S. Tripathi, Professor Sahu, and all other distinguished guests. We have Dr. Chauhan here as well, who I go back very old. Probably you will know a little bit more about me, my association with this college, which goes back almost now 40 years actually. So we will get together and come to know each other. One thing I'll say before I start actually, let's make it very kind of interactive. So as much as you're looking to learn from me, I want to learn from you as well as to what you're looking to do, what you're looking to gain. Obviously, there's a lot to say about GIAN course, which basically brought me back to this institute, but obviously you have all heard about the GIAN course. I think it's a great opportunity. It's a great opportunity for you to learn what's going on in the world. And I agree with Professor V.S. Tripathi when he says that, not 100% in the sense that, because I do not know as closely, but I'm sure the syllabus here usually lag behind. It's improved a lot. When I was a student, when I was in your place, anything that's happening in the world, in the research, would take like 5 years to come to us. It needs to get published, needs to get printed in a journal. The journal has to be subscribed. It ends up in library, and then you go get an opportunity to your hand on the library. It's improved a lot. Electronics, telecommunication, internet has changed. It's a great equalizer, but face-to-face has its own value. So I look forward to interact with all of you. Hopefully you'll get some opportunity to meet outside this classroom as well. So I look forward for all the interaction, and hopefully you'll find some benefits based on what I have to say. Right? Thank you.
Thank you, sir, for your invaluable presence and words of wisdom. It is now my distinct honor and privilege to extend a warm invitation to our distinguished dignitary, Professor Rajeev Tripathi, Vice Chancellor at Rajiv Gandhi Pradhyogiki Vishwavidyalaya, the State Technological University of Madhya Pradesh. Professor.
Thank you, and sorry to interrupt you. This is पता नहीं इंट्रोडक्शन की यहाँ जरूरत है
पार्टिसिपेंट्स बाहर से भी हैं इसलिए
अच्छा चलो बाद में कर लेना डिस्टिंग्विश faculty member from New Jersey Institute of Technology and starting faculty member of MNNIT, my good old friend Professor Prabhat Vaish, Professor Tanuj Nandan, head of the management department, Professor Vijay Shankar Tripathi, my own head of the department where I am serving, still serving na, nikala to nahi hai. And my colleague Professor G.P. Sahu, who is local GIAN coordinator, my all distinguished faculty colleagues from this institution, and my dear participants. It's good that we all are here, and everybody has already introduced a lot of things about AI. Only one thing which I would like to add here is that God has given intelligence to human being only. थोड़ा थोड़ा हो सकता है कुछ और कहीं गया हो, but that intelligence is here only. Whether AI or generative AI or whatever comes, it all comes from here, from human being. So you need to be more logical, more calculative, and these are basically the current tools for making any specific decision. So from the application point of view, it applies in all fields, whether day to day or in technical terms, technical area, or anywhere you find it. Now, why AI and generative AI today? Because of the various developments and advancements which has taken place in different directions. Maybe those advancements may have matured in isolation in terms of its own application, in terms of its own value. But current situation is that now we are integrating all these disciplines, and that is the area where almost all the technical disciplines are working in the form of integration, and AI is also one of them. Of course, computer science has got major role to play, but not only computer science, all the disciplines, even in social sciences also, today we talk about AI application development, not only application, development. That means our cognitive senses, our logical ability, that all is to be incorporated there. I think about basic introductory part, I have been told that I have to talk about, so we will talk in detail later on. But yes, I must congratulate the dynamic coordinator of GIAN program of this institute, who has reached to the level of 50.
43, sir.
43.
This is 44.
50 तक पहुंच जाओगे ना?
इसी 2 महीने में 50 तक.
Right. So that's the exact figure which came to from me, and he is the only key person. I am only for the name's sake, though I am not here these days, but even if my presence was here, he was doing all those things. So I am thankful to Professor Sahu for coordinating this event, and I am confident that you all will be benefited with this program, and as has been said by my previous speakers, that be interactive, feel free to ask questions, and let me tell you that no question is a silly question. So don't be feel shy about it that, oh, ये सवाल पूछा तो पता नहीं बाकी लोग क्या कहेंगे. So don't feel like that. Be interactive, try to get maximum out of this deliberations, have good networking. इसमें networking है ना, and have good networking in as per the GIAN. The networking is basically for academic institutions and foreign faculty, but that is extended to all the participants also. So I'm sure that you will enjoy your stay here with all logistics arrangements provided by efficient GIAN coordinator. So thank you all the best. Jai Hind.
Thank you, sir, for your invaluable presence and words of wisdom. Now I request Professor G.P. Sahu to present a token of appreciation to our distinguished guest. Sir, please do the honor. Professor Sahu, please hand over a memento to Professor Prabhat Vaish. Sir, please hand over a memento to Professor Rajeev Tripathi. Sir, please hand over a memento to Professor V.S. Tripathi. Sir, please hand over a memento to Professor Tanuj Nandan. Before we conclude our inaugural session, I would like to invite Professor G.P. Sahu, the esteemed coordinator of this workshop, to deliver the vote of thanks.
Thank you very much, Ayushi, and I'm very much thankful to starting with top down. So Ministry of Education for generous funding that we have received for organizing this program. Without funding, so such program it's very difficult to organize. So Ministry of Education, then the national coordinator for GIAN activity is Indian Institute of Technology, Hyderabad now. Earlier it was IIT Kharagpur, now it is Hyderabad, and I'm thankful to their coordination on a regular basis. Today morning at around 10 o'clock also I received follow-up phone call whether the program is on time or not. Okay, so that way they are excellent work they are doing in terms of coordination, in terms of office response time is very excellent rather. Okay. So my own institute, who has permitted me, along with Professor Rajeev Tripathi sir, to apply for this funding and providing all the facility infrastructure available here. So thanks to my institute director, Professor R.S. Verma sir, and all the office, including my head of the department, electronics engineering head. So thankful to all the officers present here for giving me this opportunity to apply, and then supporting me in all official works related to GIAN application. All present here, starting with Professor Prabhat Vaish. Without him, he is the key person present here, that he is the foreign expert going to deliver for 10 days lecture. He is an authority in this area, especially when we are looking for who can do better in artificial intelligence, especially generative AI I'm sure all of you might have gone through his profile. So his no benefit with him is that he has experience with industry and academic. So as a practitioner, as an academician, as a researcher, so all three flavors will be able to get from his lecture. So thank you very much, Professor Vaish, for accepting our invitation and coming all the way from New Jersey to this place, although it is your alma mater, so I'm sure that you will enjoy being here, and then all other places as well you'll be visiting. Thank you very much. Professor Rajeev Tripathi sir is the authority in this institution. He is our guiding lamp. Right? Whenever we find some difficulty or some challenges are there, we always visit him. And so he being the course coordinator, but I always consider him mentor for me, for the institute, for the our department, including electronics engineering department. So he's a big person. I'm thankful to you, sir, for being here. I'm not introducing, he is also Vice Chancellor for Rajiv Gandhi Pradyogiki Vishwavidyalaya, Madhya Pradesh. So beside the fact that he is authority there, he took out some time and then visited us to grace this occasion. And also we'll be listening a few hours of lectures from him as well today, and expecting tomorrow also, hopefully he'll be able to spare some time. So thank you very much. Thank you, Professor V.S. Tripathi sir, for sparing time. Thank you, Professor Tanuj Nandan sir, Head School of Management Studies, all my faculty colleagues present here. Thank you very much for making this event successful, and most important, all the participants for taking interest, registering for this course. My team members, my student team, this program is being recorded, being live streamed. So there is a entire 9 of my students continuously working for the good streaming, good recording of this program. So thank you all present here. IUC is doing a good work. Thank you, IUC. Thank you, my staff, department staff, Atul and Dhirenji is here. Thank you, everyone. Thank you. And over to IUC.
Thank you so much, sir. Now moving further, it's time for the national anthem. I request all the respected dignitaries and our respected delegates to stand for the national anthem. जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाए तब जय गाथा जन गण मंगल ध्यायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. With this, we conclude our inaugural session. Now I request all the guests, dignitaries and the participants to assemble on the ground floor for group photograph. Then after, there will be a 15-minute tea break. It will be served on the first floor. Please reassemble here after the break for the lecture. Now, I kindly invite our chief guest, Professor Rajeev Tripathi, to give brief introduction about artificial intelligence. Sir, please take over the dais.
क्या
ये
नहीं ठीक है चलो
आप कहीं भी मूव कर सकेंगे सर।
लगा दो आवाज आ रही हो चलिए thank you once again. Thanks to Professor Sahu for all the support, though it is my own course, but effectively his course. Right. So as I was telling in my opening talk that on this earth, God has given intelligence to only human being. Now, what we do, and let us analyze, if we try to analyze gradually how intelligence is built up, starting from a very childhood and going up to a matured level, if we try to analyze that, you will, at this stage, you will be able to find that what are the parameters based on which you take the decision. For example, if I say that you have to take a call on some situation where a director or the vice chancellor has to take a call on that, probably your decision will not be that good decision, because that is the first situation which you are facing, and that is what we call it as experience. Say for example, if you have to go to your management department from here, how you will take a call, how will take a decision? अच्छा, आजकल तो एक ही रास्ता है. If more than one options are available, out of all, say for example, forget about management department, locals who are here, from here you have to go to civilize. You have different options. And what is the target? What is the target? You have to reach civilize. Now, what else you want? Civilize jana hai, fine, it's okay. That's a end destination. And what you want? Mode of transport. If you have been given 3-4 options of the route, which route you will select? Shortest. But that shortest has got very heavy traffic, right? So, what is your decision? Not to go by that. I'll take longer route, but would like to reach early. I don't want to stuck up in jam and waste my time. Now, how you took that decision? You took that decision by setting certain target that this is my destination, and at this destination I want to reach in minimal time. And what are the factors which are controlling that minimal time? One is your traffic, another is your distance, third one may be something else. Now, based on all these different parameters, you have to take a call. So, what exactly you do? What you do here? This is your cognitive things
based on all those information, you decide. But once this machine has to take a call on this, how you will do? How this machine is going to do? Machine will not be able to do anything unless and until you give the input. And that's why I say that whether artificial intelligence or anything else, any advancement, any development, your brain is important, your intelligence is important. That will be used every time, everywhere, and you can sharpen the tool using your logical things. Now, coming back to the example, if I am going to give, if I say that fine, time is no constraint, but मैं जाऊंगा इसी रास्ते से because it's a shortest. गाड़ी बंद कर दूंगा, पेट्रोल बचेगा, and I'll reach there. Likewise, there can be different other parameters. Now, depending upon the parameters, depending upon your objective, you assign certain weight or priorities to those parameters. And finally, you develop a relationship. Relationship of what? Relationship of all those parameters with assigned value, with assigned weight, with assigned priority. And finally, you calculate it and fix that if this is the number, this is the path which I have to follow. If this number, this value comes higher than this, I am not going to accept. If this value is going to lower than this, that's a preferred one. And that's how you take the decision and you program your machine. That's what all these algorithms, primarily they are doing in the same way. Maybe it's a very simple example which I have taken so that you can understand, you can learn. Now, if you ask a child, a small child, that I have to read civil lines, what will be the answer? You won't get the answer. Because he or she has not been exposed to that kind of experience, that kind of situation. So, logical ability and information, whatever information you already have in your database, performing the logical operations on that information, you take a decision. And that's what, to the best of my understanding, though Professor Vaish is here, he will talk in detail about all those things. To the best of my understanding, all these algorithms, all these tools, they are doing something of that kind. The only thing which is different is that today we have machines which have got greater computational capabilities, faster computational capabilities. They can, in the example I have taken about 3-4 parameters. Likewise, depending upon the situation, you may have 10 parameters, 20 parameters, and then keep on assigning the weight, or two different algorithms, mixing the result of those two algorithms to another algorithm and then getting the result. All those things probably he will be talking about on those issues. But the basic fundamental thing is that it's your intelligence which is going to be accounted for. AI tool for developing, for application. It's basically a tool, as I said earlier also, that you can apply this tool to get accurate decision. And accuracy will depend upon how many number of parameters you have selected. And corresponding to that, what kind of priorities, what kind of weight you have assigned to those parameters. And third point is that what is exactly the relationship which you have developed. Mathematical modeling kind of thing. Now, another dimension is added to it. Once you have done it, that's okay. You are getting the results, you are applying it, you are happy. Now, today the situation is nothing is static. Environment is dynamic, and then more number of inputs at different point of time that is added there. How accurately you are able to cope up with that dynamic situation, that's another part of the challenge. And how you are doing it, how frequently you are doing, how accurately you are able to do it, or it's quite possible that in certain scenarios that relationship which you have developed earlier, that may require certain changes depending upon the situation. Now, another dimension is that computational complexity. How fast you can calculate, how fast your machine is capable of handling those kinds of situations, and that is going to decide how accurate your decision is. Even in certain critical applications, even a small fraction of mistake may lead to different results. And for that to be more precise, learning, right? And learning, as I said in the beginning, that experience. Experience kaise aaya? How it came? Experience came because you have gone through certain situations, similar kind of situation, and based on that you have learned that, well, this is the kind of situation, then I have to take this call. If this is the kind of situation, I have to take this call. Similar thing applies here on this box. That machine learning kind of thing. How accurate data you have, how accurate data set you have, then you apply to it. Apply the logical things. See, everything is here. Nothing is here. Right? Whatever here you have, that you are mapping here. That's it. So, बीच में sometimes people say that AI will replace the job opportunities, etc. I say no. It's not going to replace your job opportunity, but the job profile will change. Instead of writing simple programming, you may have to exert more on that. So again, the adaptability comes into picture as I was telling earlier, that you have a static algorithm, situation is dynamic, it needs to be dynamic. Dynamic means you have to provide all the inputs. That means your algorithm is adaptive algorithm or non-adaptive. Similarly, in your scenario also, in the scenario of placement and in the scenario of different applications, there also you have to see how adaptive you are. If you are more adaptive, you are more welcome. If you are less adaptive, chances is less. So, another point which I want to mention here is that after almost every 5 years in technology, some new word will be coined. And I'll tell you that don't be afraid of these kinds of new words. Try to dig that word. And if you'll try to dig that word, you'll find that already matured things which you have studied as a part of your course, that is coming there somewhere. And once you understand that, you will start enjoying the situation. And if you don't understand that, you won't enjoy that situation. And if you will not enjoy, again, the situation is that you won't be called as a successful professional. And on the contrary, if you start enjoying that kind of situation, success is bound to follow. Right? You don't have to follow the success. So the point is that your basics, your fundamental concepts needs to be much more stronger in comparison to past time, because things have developed like anything, and everywhere, everything, it's not possible. But at the same time, if you understand the basics, if you understand the fundamentals, then you will enjoy it, then only you will be successful. And that's what for this kind of GIAN courses are. And I'm sure that with Professor Vaish here, you will be having very fruitful session for 10 days or 15 days, for 10 days. And as I said in the beginning, that be interactive, good interactive sessions within the class, outside the class, that is going to be in your benefit. Thank you very much for providing me this opportunity. Look, please. Any questions? बैठे हुए इसलिए मैं ज़्यादा बोला भी नहीं, मैंने सोचा कि इनके विषय में मैं जानता भी नहीं।
we can ask that question here. Not going to go too much in the detail. You have the structure of the course. I think Professor Sahu has circulated that as well. I'll try to adhere to that as much as I can, but depending on how much time we spend, we may deviate a little bit, and hopefully that should be fine. Outcomes fine. I do have a link here, AI index report from Stanford University, which is what it gets produced every year. I'm going to rely on that a little bit today, tomorrow. Generally talk about it. It's a great survey of what is in the field. So feel free to have a look at it. If you have checked out, and by the way, this was supposed to be a day zero thing, so I'm just going to use it as an icebreaker a little bit so that you can to know me and I can come to know you guys a little bit. If you have seen me on LinkedIn, great. If you have not, feel free to reach out and then connect, and if you want to do something or the other. All right. You heard about it. I was in this college 40 years ago. On the other side, I was a student, 1984 to 1987. Ours was the first batch of MCA, actually. First artificial intelligence course was taught in 1987, I believe. Our batch was actually, we were the catalyst. We forced the institute to actually have an AI course. The person who taught that course, actually, I'm in touch with her, and I wanted to basically make sure that I refer to it here. The institute has a history of basically bringing a lot of path-breaking technology. You can imagine, like in 1987, we had a course on artificial intelligence. I came back here, I'm not exact sure, 92, 93. I actually did teach the AI at that time here. Things have changed a lot from those days until now. Even the textbook that we followed at that time in 92, 93 is no longer in that form available. So things have changed, obviously, and we're going to see what exactly is going on here. Has anybody attended, I mean, obviously you're doing a research on the using some of the techniques. Has anyone done a course on AI, have studied AI outside that? Yes, no, maybe? You have done it. Okay. As an undergrad? As a postgrad student. Okay, great. So one other thing I wanted to start with, and I mentioned that the AI index report, just get a feel of where the discipline is, where exactly it's going, what exactly is going on. And one of the best way to rely on this, the Stanford, as I mentioned, published, I'm going to refer to 2024 report. Next month, in January, they're going to come out with the 2025 reports. So this is based on whatever was happening until 2023, right? So this is a pretty fun next maybe 20 minutes or so, just so that you know where exactly we are going with it, right? So top 10 takeaways. And this report talks about, like, I think 20 different sections, and each of these has 10 takeaways. These are the top 10, right? Okay, so AI beats human on some tasks, but not on all, right? Do you all agree with that? Yeah, I can peel the banana, I cannot yet do it, right? There are robots which can do a few things, but not everything. Now, the second point is very US focused, but I'm sure you'll probably understand this. Not very good, even in the academia. In US, people are concerned about it. But the fact of the life is that most of the AI research is happening outside the academia. It's the private industry which is really working more than the academia is working, at least as of 2023, even in 2024 also it continues. The frontier model gets way more expensive, a lot of money, lot of training effort, a lot of data, a lot of compute power that is required, and they're getting more and more expensive to produce the newer model. US obviously is number one in the research right now, China followed by the European Union, UK to a little bit. Majority of the models are still coming out of the US. Evaluation, especially on the standardization evaluation for various models that are coming in, is something that's seriously being considered. I am part of one of such evaluation committee which is focusing models for the healthcare. That's something which is very actively pursued all across the world. including in India. I'll try to pull in some stuff about work being done in India towards the later part of the course. But in general, there's a very, very heavy focus on evaluating the models, making sure that they work as they claim, right? There's a lot of investment that is happening. It's unbelievable amount of money that's being put into the AI research. It's just going all along as we continued. Hopefully we'll continue for another 5-10 years, so the investments are going to be all over the place, right? AI is being used by the companies quite a lot. It makes workers productive. There's higher quality level work that's being done as well all along. As Professor Tripathi mentioned, it does not necessarily mean that the jobs will be replaced. The nature of the job will change and is changing. So that's happening, making workers more productive, right? The number 8 here is a questionable thing, but then that's what is happening here. Is the AI helping in research? So clearly there's a research which is helping the AI, but is AI helping in research? That is also happening where the scientific progress is accelerating even further. So the areas, for example, like protein folding, area where we are trying to do the experiments modeled by the AI rather than doing them onto the real subject. So it's working both ways. The scientific research is also being benefited by the AI. The AI regulations are coming in. So this usually happens in the sense that whenever there's a new technology, there's going to be regulation, the regulations will come around. So regulations are coming, and in US especially, India also is trying to get their own set of regulations. But in US, there are regulations coming all along. As a matter of fact, last week, there was a new report, a new regulation that was introduced. The regulations are from all over the area in the sense that they could be as individual. Can your image be used to train the AI? Can your emails be used to train the AI? Up until now, there was no regulation prohibiting the large companies making use of your data. That is happening. How you specify what your data model can do or should do. Now, a lot of these regulations are coming because of the studies. In US, for more than 10 years, the AI is being used for sentencing purposes. If you make a minor infraction, you go to the court. It's not the judge which is making the first call. It's the AI that's making the first call to determine what should be the judgment, sentencing judgment for you. It's not the final, but it's basically as a help for the judge. That has created, it led to a major research and came up with biases depending on who the person is. It says that you show me the face and I'll show you the law, right? It happens in various ways, but even AI has no immune to it. Depending on who the person is, it's showing the biases. So regulations are happening all the time. Everywhere other than the US, people are realizing that there's benefit to be held from AI. So there's more and more people becoming familiar with AI outside US as well, right? So, top 10 takeaways. I do not expect them to change in 2025 when the report comes. They might change, I'm not sure. Hopefully, I'm here till January 10th. I think the report is going to come after January 10th, but feel free to have a look at it. It would tell what is 2024. I think one other thing that will change possibly is what is happening, and I'm not sure if many of you have heard of, AI is running out of data. So that is where the problem is right now. And one of the days I'll show you what happens when the bad data starts feeding into the models. So where we stand right now, and as I said, it's a very kind of, if you think about it, it's a very dangerous statement that the AI is running out of data. Without data, there's no intelligence or no AI. And actually we'll come to that. We'll just figure out what is intelligence, right? I think also this morning he mentioned it's all here, right? So let's talk about that for a few seconds and things like that, right? Now many of you, is there anyone here who did the information technology or informatics or something to do with that? Any courses in information technology, IT? Okay. What is information? Sorry? Data which has a meaning. Can there be a data without meaning? When does the data become information? Okay. So if you think about it, the data is something that you observe, right? Because anything that you are observing becomes the data. If you start seeing a pattern in a data, that's when you start taking out information. The data itself may not convey a lot, but when you start seeing the pattern, you're getting the information, right? Now, when does information become knowledge? It's kind of important because we're trying to learn artificial intelligence. Let's try to figure out what is intelligence before we make it artificial, right? What is knowledge? Yes?
When the information is applicable, then it becomes knowledge.
Okay. So when you start applying the information, you say that you have a knowledge. Does the knowledge come first or the information comes first? Sorry? Okay. Is it possible for someone to have a knowledge without having an information or any information? A baby is born, he or she knows how to suck the milk. That's a knowledge. There's no information. This is an active area of research. What is innate knowledge? So up until now, what I said, that you start with data, information, and then you get to the knowledge. And I agree, whoever responded here, in the sense that when you learn to apply information, that becomes knowledge. But not all knowledge is acquired. Some knowledge is innate, right? And when a baby is born, nobody is telling. The baby will learn a lot by observing, right? Observe, which will be data points, it will get converted into information and then knowledge. But there's something which is innate. So, yes, the data leads to information, which leads to knowledge, but not all knowledge is acquired. Some knowledge is innate, and that's what we are going to be doing or seeing some research as well. What's learning? Guess. So, the process by which you actually turn your information into knowledge is learning. If you think about it, right? All of you are getting the same information. Well, are you learning the same way? Right. So the process of getting your information converted into a knowledge which you can apply is learning. Now we'll come across this term learning many times in the next 8-9 days. How? Because we're going to be talking about machine learning, right? If we want machines to learn, we got to know how we learn. And what did we say? We learned by converting information into knowledge. That's what is learning. So the same way we'll see how we can make machines learn, right? See, anything if you want to teach a machine to do, first of all, you got to figure out how, as a human being, you and I do it, right? And if we know how we do it, then we can possibly find ways to have someone else learn it, right? So we'll continue to go talk about, focus would be how to make machines learn, and then the learning will come from data, information, and knowledge, right? All right, so how does it lead to intelligence then? What's the difference between intelligence and, let's say, knowledge? Learning was the process of converting information into a knowledge. If you are knowledgeable, are you intelligent? Or the vice versa, if you are an intelligent, does it always mean that you are a knowledgeable person? What's knowledge and what's intelligence?
Sir, I think it's extracting information from the data using learning.
Okay. Anybody else? We're going to be talking about intelligence as well, artificial intelligence, right? That's what we're going to talk about. But what is intelligence?
Taking decisions, right?
How about this side? Nobody's saying anything? Sorry? Okay. You're very close, yes.
Ability to use the knowledge learned.
Yes. So in a way, if you think about it, when you are learning, right, you are tested in the exams, right? They're testing your knowledge, right? The intelligence is when you use your knowledge in unforeseen situations. When you are being tested, you are usually being tested, you're tested for your knowledge, which is the process of learning, which gave you knowledge. That's what you're being tested in. Majority of the time in a classroom setting, you are being tested on what you have been taught. That's not intelligence. Intelligence is that making use of that knowledge in unforeseen situations. So can someone tell me what's the relevance of me talking about it? If you are teaching a machine learning, and ask it to reproduce exactly the same thing that you taught it, it's knowledgeable, it has learned something, it's not necessarily intelligent. The intelligence will come when it can apply that knowledge in situations that has not yet been seen. Does that make sense? Right? So if you teach someone whatever it is, and that's where the difference comes. Somebody can learn a skill, and it can be very skillful person to do that job. Knowledgeable, sure. Can't say intelligent yet, because the intelligence would mean applying that knowledge in the areas, things which you have not seen. Right? Those of you who are doing research here, if you think about it, the key difference, majority of the time, in a typical graduate school course and a research is that at the postgraduate level or graduate level, as we call in US, you are acquiring knowledge. When you are involved in research, you're trying to take that knowledge into some unforeseen area, unrelated area, or a totally different way of doing things. Make sense? Okay. Has anyone heard the term called singularity ever? What is it?
In cosmology, like the point where everything is concentrated.
Okay. So singularity, there's this guy named Ray Kurzweil, actually he introduced the word. That's the point where it says that the machines become smarter than the human. So the singularity is defined in terms of that the machines become smarter. Now when will the machine become smarter? When they become intelligent. Right? Has anyone seen the sci-fi movies when the machines become important?
Yeah.
Okay. Who thinks that the machines are going to become important? Intelligent or smarter than human being? So Ray Kurzweil predicted that by 2045, the machines will become smarter than the human being. How many of you think that 2045? Many of you are young, you will be seeing 2045. I'm not sure about myself whether I'll be around in 2045. You think the machines will become smarter than 2045? Okay, I'm going to ask the question slightly differently. This year, 2024, so this was a book he wrote, Singularity. He wrote another book this year called The Singularity is Nearer. And his latest prediction is 2029. So not even 2045, but 2029. Now who thinks that in 2029, the machines will become smarter? Any idea? All right. Let me go back to something that, again, Professor Tripathi referred here, that the human being has been endowed with a lot of intelligence, right? That's what he says, that the human being. So what makes us intelligent? What is it that we as a human being have which not many other species in the universe have? Is there a marker or anything? No? That's fine. That's fine. This will work, right? Okay. Okay. So, what are the what makes human being intelligent, or what makes us different from rest of the other species? What do you think? And I'm going back, trying to get our own answer. Are machines going to become smarter than human being? What makes us as a human being better than the other species?
Creativity, innovation.
Okay, let's see if we can go to more basic stuff. We've got 5 senses, right? What are the 5 senses? Okay, touch and see, hear, smell, and 5th one? Taste. Okay. Can someone think the machine becomes smarter without actually doing all 5 of these things? Okay, let me ask the question. What can machine do out of these 5 things today? Yes, it can see, it can hear. That's where it is right now, actually. I mean, if you notice that majority of the AI machines are focused that they can see, they can hear, and obviously interpret it, right? Automated vehicles or self-driving car is probably one of the most important AI application which is commonly used by the people, right? So, from one set of, not everybody kind of agrees, but that's how I define it. The machines have to learn to feel touch, smell, and taste before they can take over us, right? What else differentiate people from machine? Emotions. Which emotions? Any specific emotion? Okay. So, sorry?
Sympathy, sympathy, these kind of I don't think machines are not right now capable of doing that.
All right, we'll come to that. What are the 2 common emotions? Emotion, I agree, emotion is the one which is where I'm going. But 2 most fundamental emotions that define human being. Sorry? Happiness and sadness. Okay. Anybody else? Has anyone heard here the name of a sociologist called Yuval Noah Harari? See, there's a negative point. I'm not a pure technologist, so some of my examples will come from the other areas. He's a Israeli social scientist, and he has written a very, I mean, he's one of the great guys. He's written a lot of books and a lot of things. So there's a book that he has written called Sapient. Has anyone ever heard of it? Okay. What does Sapient talks about? There were 2 major species, the Homo sapiens, which we are, and Neanderthal, which was another group of species. Neanderthal lost, the Homo sapiens won, and we're talking about like millions of years ago. We are all the descendant of the Homo sapiens, basically. We are Homo sapien, right? So his research shows that one of the things that Homo sapiens had and Neanderthals did not have, can anyone guess what it was? Yes and no. Neanderthal also communicated with each other. But the research shows that the Homo sapiens had one thing that Neanderthal did not have. Okay? So that's one of the emotions. It is an emotion. And one more fundamental thing which defines the human being.
Caring for each other.
Sorry?
Caring for each other. Care for each other.
You guys are so nice. Those are the two emotions that actually define the human being. Nothing happens in the world unless there is a gossip involved and there is a greed involved. And greed is not always a negative term. Everybody who's doing research here is greedy. They're trying to find something which no one else has found and they want to find it first. That's a greed. So the greed is not neither gossip nor. How many of you have done telecommunication? There's a protocol code named gossip, right? So don't think that these are only negative connotation terms, right? So these are there. So basically what I'm saying is that yes, there is a risk that the machines will take over. Will it happen 2029? I don't know. And my logic is that they don't yet know how to gossip. They don't have greed as of yet, at least demonstrable. On these sites, the taste, smell and touch, it's a matter of time when the machines acquire these skills actually. Whether it happens in 5 years, 10 years, 20 years, we don't know. Right? Gossip and greed. A little bit of more anecdote. I don't know if many of you, some of you may have heard about it. How many of you are familiar with CAPTCHA? You know it, right? So one of the tests was given to a generative AI system to say that, to test, because this is really see and feel, can it solve the CAPTCHA?
So there was a first Facebook's AI bot were talking to each other.
Yeah.
And that doesn't come under the gossip. Just because that was not programmed.
Talking is one thing. The gossip is when you are not necessarily have instructed it to talk.
Even it was said that was not in their program to.
No, we'll come to that. It's called emergent behavior and I'll talk about that. But the gossip is something totally different. When you gossip about you know what the gossip is, right? So it's not happening there. But let me just go back to the point I was trying to make. The generative AI model was asked to solve CAPTCHA problems. Okay? Guess what it did? Can someone guess it? If you know the story, then it's a different thing. Otherwise, guess what it did? The CAPTCHA problems were something like it needs to find a number and then it had a like 2 plus 2. The model hired human being to solve on behalf of it because it knew that it can hire people, so it hired people. So the machines are getting smarter, but yet not, because they don't yet have gossip and greed. Eventually they'll get to this. All right. Anyway, so you guys have seen the schedule. We'll go into that list. I'm going to skip this. We'll talk about many of these things in these orders. Any questions at this time? Yes, no, maybe? My greed is that I want you guys to ask questions so that I don't have to speak less. Okay, no, that's perfectly fine. Last opportunity. Any question?
What if machines become smarter?
Sorry?
What if machines become smarter?
What if machines become smarter? There are multiple ways to deal with that.
How we will?
Yeah, so if the machine becomes smarter, we will be happier in the sense that they will do more of our job, right? I don't need to make coffee, they'll make the coffee. Okay, that's a good question actually. So how do you define employment? So see, the employment is basically the means of production and getting someone involved into a specific means of production. Means of productions have changed over a period of time, right? So if you think about it, and I'm talking about when I was in your seat, basically, right? There used to be video cassette players, and there were video cassette recorders, and there was an industry which basically used to rent video cassette players, and you rent them and get them in the hostel and watch 3 movies overnight. There used to be the video cassettes. I don't know how many of you have seen the video cassettes, right? That industry has disappeared now, right? Now, one can say that those people became unemployed, right? So, whenever there is a change in technology, the mode of production will change, which means some people will have to retrain themselves to find an opportunity into something else. So that will always happen. So we cannot say that this can cause unemployment, because every time you change the mode of production, some people who were employed using old mode of production will go away, right? When the cars came, the bullock carts went away, right? So these things will happen, and that's how the progress happens, right? They continue. Any other question?
So one question.
Yeah.
What if human and machine will be combined? There's a machine which is already trained with all data, and the brain used by humans. Like I have a hand. I'll replace everything by machines, and which is still trained.
So there are 2 ways to look at it, and good that you clarified that. So there's one thing that the machines are getting embedded into human. So that's one part of it. Some of our organs are being replaced by electromechanical. Some of us may have it, right? I know people who have a switch inside their heart which can trigger and things like that. Now that's one thing. It's like transplant of a machine. When you started a question, I thought you're going in the directions of cyborgs, which is really, yeah.
Like there's a machine already trained, everything trained. Like after 250, 60, and human can be died, right? If someone can replace the
Okay, so we're going a little beyond in the sense that, because we talked about getting intelligence, but we didn't touch one more thing, which is what a human species does, which is the procreation, right? So what you're talking about is way far out there, where you're saying that can machines procreate or produce the offsprings, right? So all of it is the sci-fi world right now. I don't think we are anywhere close to that. We are somewhere here, and I'm not going to make any predictions. At some point of time, we'll talk about it, what the AI used to look like in 1987 when I studied for the first time, how it was in 90s and then in 2000, and what changed. As a matter of fact, in the next hour, we're going to talk a little bit of the history, a very quick summary of that. Are we reaching to that point? I don't know. I'm not sure. We'll see. Sorry. Yeah.
We talked about gossip and greed. So how will machines stimulate gossip and greed? Because in the end, they are a bunch of numbers. They are machines. Do you think it's possible for them?
Okay. So one of the things which is very active research, and also the current focus where we are, is actually talking about agents. Has anyone heard of the term agents? The research in the AI is actually in this space a lot. Once you say, so the agents, if you can think about, is a program. It's a program, basically. It's an intelligent program which has a life of its own, in the sense that it is tasked to do something, and it's continuously monitoring an environment or whatever it is. When the agents, and these agents can interact with each other, right? Those agents are the first candidate that they may become greedy. Part of the reason is that they may become greedy because they may have been programmed to do that. So think of an agent, for example. Now, I'm going to give a few examples which are probably apply more for the US market rather than the Indian market. So think of it this way, the prices fluctuate in the US market. I think here also now, let's say you're trying to find a flight for Mumbai, right? The prices may not fluctuate as much here as they do in US. You may train an agent to look for the best price for you. So by definition, the agent is greedy because you have trained it to look for the best price for yourself. So the greed is always there, but there's a greed which it has been asked to do, but it can generate a greed of its own also. Right? It's always possible. And then those agents can start colluding and then have gossip and whatnot. Right? So it's possible. And as I gave you an example, when we asked the model to solve the CAPTCHA problem, it figured out, nobody told it that you can hire humans to solve it for you. It hired humans to solve the problems for itself. So we're not there, but it's happening. Okay? All right. Let's get to what we are going to do, the actual focus of this program. So this was just a little bit of an introduction on myself and then things like that. So let's try to get started and get a quick overview of what the AI is all about. We will do a little bit of historical viewpoint, and then from there try to reach where we are today. So hold on with me for a second. Okay, so we'll try to cover as much as we can today, and then we'll continue wherever we are stopped. I don't know when we stop. Whenever Professor Sahu tells to stop, we will stop. All right, let's think about it. What was happening in AI? How many of you had heard of generative AI or large language models 5 years ago? Sorry? Okay. What have you heard?
Like it's the machine which can do the work. When we talk in the simple languages, it will do the work with the help of their data.
Fair enough. But what I'm saying is that when did you start realizing that it's real or something is happening? When did you come to know about machine learning, large language models, generative AI for that matter? When was that?
Around 2-3 years.
Okay. Anybody else?
2 years back.
2 years back. Yeah. Sorry?
So Google Assistant.
Okay. What is intelligence? What is intelligence? What do you think is intelligence? I mean, we talked about it a little bit earlier, and I'm just kind of digressing a little bit. The point I'm going to try to make in the next few minutes is that it happened gradually and then suddenly. So in most of the fields, what happens is that there's incremental change, there's small changes, and then suddenly what we call it like a Rubicon is crossed, and then you see it everywhere, right? So what is intelligence actually? Like, when does a machine become smart or intelligent? Or my question, in a way, if I rephrase it, is that when did you think that, oh, that is smart or that is intelligent? Something that basically wow you.
So when it becomes difficult to distinguish whether a statement is given by machine or the human.
Okay, so you are going by in terms of the speech or text or something like that, right? Is that the only way to define the intelligence or smartness, or it could be something else? What else can it be? How many of you have used the Microsoft Word? When did you start noticing that it can actually do autocomplete your sentence? Is that intelligence? Yeah? Okay. How many of you have noticed automation, a door opening for you, let's say, automatically? Is that intelligence? Okay. So, what's your name? Yeah? Durgesh. So, Durgesh said something here which is important. I mean, he may have said something, but what I realized or what I gather is something different. He says that if I know how it's happening, it's not intelligent. If I don't know, right? So you're saying that, oh, I know it's a sensor based. And that's a fact. If you know how someone has done it, then I know how it's being done. Otherwise, it's magic. So when was the AI magic that you felt? Okay, all right, we'll come to it. Let me say that. My first job was in Mumbai, 1987, okay? And I saw the door opening on its own, and I thought, wow, that is something. I don't need to open it myself. I just walk in. I didn't know that. It's a sensor. So that was a magic for me. No, I'm just saying that. In any case, anything intelligent is that if you do not know how something is being done, then you realize that there's some magic happening here, or there's some intelligence that's out there. Okay? So what happened if you think about it? This is all the 2024. All major magazines, Science, Economist, Time, Cosmopolitan, had a cover story which talks about the intelligent or talked about the some kind of machine learning. Right? Now, what happened in 2024? Many people came in the contact of something that they realized that it's like something magical, intelligence, learning, or something of that nature. Right? So, when did it all start? So, many of you may have heard about it. Dartmouth is one of the universities in US. In 1956, they brought together 10 researchers to figure out what would the AI be. Actually, they coined the term called thinking machines. That's what we were trying to do. Those 10 scientists came together and they basically predicted that in 10 years they will have smart computers. Obviously, they were fantastically wrong, but that's what they started. They were trying to think about it. I think I have a statement which will come in here. From 1956, it took 40 years for first computer to beat a chess player. And by the way, chess is not one of the most difficult games to acquire for a machine. Has anyone heard the game called Go? And it's not like chess, it's slightly different from chess, but way more complicated or way more difficult for a machine to learn. And we will see that the computer scientists were not necessarily satisfied when they actually beat the human on chess, because I'll tell you what the difference between chess and Go is, that they waited until they get a machine that can beat the Go champion actually. And that also did happen. So anyway, this group of 10 scientists thought that in 10 years they will have a thinking machine. It took 40 years for IBM supercomputer to defeat world champion Garry Kasparov in chess. In 2011, there was another Rubicon was crossed when the IBM Watson computer defeated game show Jeopardy. Has anyone heard here the Jeopardy? The game Jeopardy, and why this was important? So Jeopardy is a quiz game, but in a reverse way, in the sense that you're not asked the question and given the answer, you are told the answer and said, what was the question? So it's the reverse way, and the computer became smart enough to defeat the Jeopardy champion. Okay? And then Obviously, the DeepMind, which is a Google program, has been involved in trying to do the predicting the 3D structure of the proteins, which is happening very recently. All of these were the stepping stone to where we are today, but you would see how things are changing. Now, if you think about it, I said something that the chess is great, but not by computer scientists. It was treated as one stepping stone, but not really. Was it intelligence here? What do you think? Or was it intelligence here? What's the difference? What happened here? And this will actually, if you think about it, will go back to when I was a student 50 years ago, 40 years ago actually, exactly, or 44 years ago. We were learning in artificial intelligence. What is this? What is happening here? Has anyone written a program like a chess player writing a code to write? We'll talk about this a little bit more, maybe today, maybe tomorrow, but what exactly was happening in the program that defeated a chess player? I can rephrase the question, and some of you who are involved in research actually should really know this by hand, and I'll be able to answer this question very quickly. So what is happening if you think about it? What is an AI program? Let me ask this question. If you have ever written an AI program, what it is? What does the AI program do?
A large number of results.
Okay. So one other thing I always tell my students actually, and if you take just one thing from me, learn to answer the question succinctly. Okay? And I'm not saying anyone, but then if you learn, this is a skill that will come, but use the right word, use the right amount of words, and then see if you can convey it. So the basic point of your answer is correct, but it has to be said in a slightly different way. That makes sense to us. So it's the same thing. If you're trying to explain, let's say, algebra to a third grader, you would explain it slightly differently compared to, let's say, a high schooler, compared to a grade student, right? Okay? I'm not going to ask what algebra is, because 9 out of 10 of you probably wouldn't be able to give me a right answer of what is algebra. Okay, let's leave that aside. Anybody who wants to know, talk to me after that. Okay, so what does an AI program look like? What does an AI program do?
It basically predicts the output based on the training and testing data.
Okay, all right, let's see what you said. It predicts. And what else did you say?
Based on the data it was trained.
10-year data? Is that something you said?
Based on data.
Based on data. Okay. Okay.
And for further tested within data.
How many of you agree with this, or is there anyone who disagrees with it?
A large amount of data provide correct prediction.
I will say that's statistics. That's regression analysis. What's so special about it? Right? Huh? Right? Listen, there's no right or wrong answer here. Okay, so the point that I was trying to make here, and when we meet tomorrow, we'll probably need a little bit of eraser and duster also, not today, but it's fine for now. So what does an AI program do, right? If you think about it. Actually, let me ask this question before we go there. How many of you have written programs? Everybody has done programming, right? What do you do in a programming?
We write algorithms and logics.
Okay. Okay, so there's a goal, right? You are trying to achieve. I'm sorry, I know you have to move around. I have a habit of moving around here, so sorry. I'll try to hold on to one place. So when you are writing a program, you have a goal in mind, right? There's always a goal. Whatever that goal is, you want to add 2 numbers. By the way, the first meaningful program that I wrote in 1984 was generating a perpetual calendar. So it's like one page. We had a small line printer. How many of you have seen line printers? No, you used to print one line at a time. So use that to print like an A4 page perpetual calendar. Anyway, so that was the goal. So when you're writing an AI program, you always have a goal, right? A typical AI program is looking for a solution among a large number of potential solutions. You understand what I'm saying? So an AI program defines, I mean, all of you are right who says data, algorithms, that's what it is. Data plus algorithm equal to program, it's all good. But then what's the AI program? So AI program, what it is doing is that it has a goal. It has a large search space which is of potential solutions. And all it is doing is that it's trying to find an optimal solution for that search space. How many of you, a couple of you says that you've studied AI, A star search, AO star search. Has anyone heard of those terms? No? Okay. All right. We'll see. Hopefully you will learn some new terms at the end of this. AI program is basically organizing the solution space and finding the most optimal solution. Okay? Now, how do you find the most optimal solutions? It may happen, as the example I think Durgesh he gave, is that you have 10 years of data and you determine, not the program, you determine that the optimal way of finding the best solution is to do a regression analysis. It's very much possible. That's one way of effectively searching your search space. That's one way. But there are other algorithms called A star and AO star algorithms which are basically searching the solution space. And then depending on what your optimization function is, it can go very complicated. We'll talk about some of those in the next few days. Anyway, so that's what is the AI program. Now, the reason I digressed a little bit, if you think about it, what did the IBM Deep Blue did here? Imagine what the programmers here in the Deep Blue did. So think of it, they were writing an AI program. Their goal was to defeat the grandmaster. How do you defeat the grandmaster? By capturing the king, the opponent's king. How do you capture the opponent king? You need to know all the rules of the game, right? And nobody mentioned data structures, or I don't know if someone mentioned, you need to find a way to represent the state of the game, which is a data structure. So if you think about it, see, in 1997, this was magic, right? But I imagine the people sitting in here should not be magic. All they did is that they came up with an efficient data structure to represent the state of the game. They wrote an algorithm which had all the rules of the chess. And what they did, they actually created all the moves that can be done from a given how many of you know chess? Many of you, right? So given a state of the board, you know which moves are allowed. What they did is that they said, okay, Kasparov can think of 20 moves at a given point of time. If the Deep Blue can do 21 moves before it makes a move, it can win. So all they did is they find out an efficient structure to represent the state of the game, have all the rules of the game programmed, and calculate fast enough, it was a supercomputer at that time, so that it can calculate. Actually, the Deep Blue was calculating 40 moves in future before it makes a move. And eventually they defeated the human, because the human was going 21 moves in future. Like before the Kasparov was making a move, he was in his mind evaluating 21 different moves that if you do this, I do this. If you do this, then I will do this. That's all it is. So just like you said, it was just sensor. Oh yeah, this is just a data structure and algorithm, right? So any AI program is doing just that. You're defining a search space, you are defining an optimization function, and you're trying to find the best answer. That's all you're doing. Okay? Now, depending on what area you're writing program, these three pictures, all of these three have been generated through AI. You see the difference there? That's 2018. That's 2023, that's 2023. You see that they're becoming more realistic. Where we are today with generative AI, it can generate a very real looking videos also. It's just getting better. Yeah? Two videos. Both of those are fake. One is showing Pope, the other one is showing Donald Trump. Videos generated fake. Right? Has any of you seen, have you seen the fake audio or fake video examples? And they are good? Yeah? Okay. So, what exactly happened here? Is it the technology improved, the data structure, algorithms, or just that we have better computers, faster computers? If you think about it, what I'm saying is that why are we even spending time 2 weeks here trying to learn something? What changed? Did anything fundamental change in the last 5 years? I'm assuming that nobody answered this question. A couple of you said 2 years, 3 years, when you start realizing that, okay, AI is happening or generative AI is happening. So what changed? Is it just because that we have faster computers? Is it just because we have more data? Or did something fundamental change in science or computer science or machine learning? Any idea? Sorry? More users? Okay. All right, so this is an example. This is the question that we will continue to answer or continue to seek answer for in the next few days. Because if you don't know what changed, and especially those of you who are trying to do the research, if you don't know what's changing or what's causing the change, you don't know where the change is taking you. As a researcher, you've got to be ahead of what the other people are doing or thinking, right? So you've got to think about it. We'll keep coming back to this question. At the end of the day, if you think about it, three things what we talked about, right? There's algorithm, there's data, and there's the computing power, right? So as you're thinking, as you're going through, especially let's say the first 4 or 5 days, try to form an opinion. What do you think happened here? Did we get better algorithms? Did we get a lot of data? Did we get the compute power? All of it? None of it? What basically happened so that you have a ChatGPT now? Is ChatGPT good? How many of you have used it? To do what? Everything? Can it do multiplication? Aye. So those of you who have used it so much, I'm going to start asking questions from tomorrow onwards. How does it work? Okay? All right, we'll see. So my point here is that we'll continue to talk about this for the next couple of days, but think in your mind as to what changed, like what happened. Did it literally the algorithm, the data, or the compute power? Right? And keep in mind the line I said, it happened gradually and then suddenly, because really that's what happened actually. All right, we'll continue to look into a few of other things here and very quickly. Very early, how many of you have heard the term expert systems? When I was studying AI, which was 1987, 86, the expert system was the flavor of the day. So if you think about it, the expert systems were basically saying that some experts will create a knowledge base, and then there's going to be an inference engine which was supposed to be an AI brain, and the users will query it. You may have heard of IBM Watson. IBM Watson has been designed as an expert system. That's how they were doing. If you think about it, IBM spent billions of dollars on Watson because it was the flavor of the research at that time, and they found that they have reached a ceiling that they cannot go beyond it. Always keep thinking in terms of when I said what is AI programming. Knowledge base was all the data. The inference engine was an algorithm that's being used to basically predict or find the right answer that's going to be. So that's what you're doing. That's what basically was the expert systems were doing. Can someone tell me, if you have not expert systems, that means that this did not go too far. What was the problem here? Or what do you think happened so that they did not succeed as much as people thought that they will. If you can answer, that's fine, because we're going to come back to this and see. Something must have changed from here to the generative AI, which made the generative AI more powerful, successful, or whatever the case may be. Any guess here? What did not go right? Okay, fine. We'll come back to it, or just keep thinking about it. So expert system was one thing that was there. Then came the predictions, what we called as the predictive AI kind of thing. The thought process was that if we can have a program predict what's about to happen, that's AI, right? Because it's predicting something. So we started with saying that what happened, which is what the MIS systems were doing, what happened. Then it becomes why did it happen, diagnostic analysis. Then try to predict what will happen in future. Then how to act in the future, right? So you went from hindsight in the sense that what happened in the past, to insight, what is happening right now, to foresight, that what is about to happen or what will happen in future, right? So the AI went from answering the question. Keep in mind, I said AI program always has a goal. The goals keep shifting because you achieved from giving you hindsight, which is typical MIS reporting, to getting into the more operational insights, to going into the predicting what is about to happen or what could happen. Okay. Any questions based on so far? Though I have left you with a couple of questions, right? Keep thinking about those things, and then, but any questions from anyone?
Sir, computing power.
Yes.
Computing power of AI.
Yeah. Okay. Not the computing power of AI. My point there is that, and we haven't answered that question in the sense that there are three things that have changed. The AI is running on a computer, and that computer is becoming more and more powerful. So I don't know what exactly your question is, but my point here is that three things may have changed or potentially have changed: data, algorithm, or the computing power. So the computing power has definitely gone. And if you remember the top 10 trends that I was showing, the specialized computers are being designed. How many of you have heard the company name NVIDIA? Why is it popular or famous? Right, because it has a computer or a CPU or a GPU which is being used to train these machines. So that's the compute power. So I don't know, unless you have a more specific question, because we are going to continue to examine what changed, the data, the algorithms, or just the compute power, right? Anybody else? Okay, all right. Yeah.
Is it possible that machine can in future change their algorithm? This can also no need human interaction that time. So automatically it can change their algorithm to think something.
I'm not 100% sure if I'm following your example. If you are saying that, can a program change itself? Right? I mean, yeah, you can do it today itself. You don't necessarily need, I mean, again, what is intelligence? I mean, if you don't know how it's happening, it's magic, it's intelligence. If you know it, then your answer will be, okay, it's a sensor. How many of you have written a object-oriented programming and a feature called introspection? Is anyone familiar with introspection? Come on. No? Can an object query itself? Right? That's called introspection. So, you can write a program where an object can introspect and then take an action based on what that object is. That's changing the program based on what that object is. Many object-oriented programming languages allow you to do that today. So theoretically speaking, if I understand your question correctly, the programs can change themselves today or change their behavior at the runtime today. So is it intelligent? Yes, it's intelligent because it's responding to an external stimulus and changing its behavior. Is that intelligence? Now, we'll continue to ask that question, right? Okay, all right, let's continue and then move on. What exactly is machine learning? We kind of defined a couple of these terms like data, information, knowledge, learning, intelligence, right? So we'll continue to define that. We'll continue to think in terms of what is it that is going to help us do this. So let's try to get a little bit more theoretical. I would say theoretical actually. A word is that like more formal in terms of what is machine learning, right? Because that's what the focus is in the next week and a half, right? All right, this is a very busy slide. Oh, I don't like it, but anyway. All right, you read it. Ask the question. Okay, next time if I use this will be broken down in two different ones. I'm not blaming a student here who did this, but this is too much on a slide. Okay, a lot of these things are very similar to what I've been talking about it in the last hour or so, right? The learning is you're using some task over and over again. That's what part of the learning is, right? Now, what the learning does to you, it either gives you something new or different. Does that make sense? When you learn something new, when you learn algebra for the first time, right? Imagine yourself learning something new for the first time. So I would say that, I'm sure all of you have done the mathematics, the three things which changes life, actually I shouldn't say three, let's say four things, which change life significantly in mathematics or in engineering or in anywhere when you first time learn algebra. Okay? What's the second most important thing when you learn something new? Calculus. The second most important thing is calculus when you learn the calculus. Linear algebra or matrix calculation. If you do not know the matrix calculation or linear algebra, you probably would never learn machine learning or AI. Without matrix, there's no AI. Or without linear algebra, there's no AI. Fourth thing. Sorry? The vector is included in linear algebra actually. I'll include that in there. Probability. The word is not definitive. It's always dealing in probabilities. If you do not know probability, you wouldn't really go that far anyway. All right. So learning, we talked about quite a few things. A computer system learns if it can improve its task on something, whatever it is that it's doing. Most of this stuff, I've talked about it, is very theoretical. I don't like the slide, but it's there. It will be in your notes. You can look into it. But the bottom line here is that the learning should be affecting or changing how exactly a computer system is behaving or responding to certain tasks. Yeah? I'll move on to something else. Now, this is more interesting task, more interesting slide that we want to talk about. Some of the things that I mentioned here is that what is going on is that the learning is getting or improving in terms of visual perception, speech recognition, decision making, language translation, a lot of these areas which are being active, which are being effectively utilized by the machines, and then trying to get to make the machines more intelligent. And they're doing it by learning. They're learning how to do it, and they are becoming more and more intelligent. Now, what is happening? As I said, that the goal is to go as close to the human being here. So they are trying to mimic human cognitive functions. They haven't yet get to the point of empathy, sympathy, or greed or gossip yet. But they're there at this point of time trying to analyze data, which was the very first thing they started, trying to understand languages. Natural language processing has been part of the AI for decades now. Recognizing images as far back as in 1980s and 1990s. When I was a student, the image recognition, image processing was part of what was happening in terms of the AI. And making predictions, obviously, somebody mentioned predictions here. Right? We talked about the expert systems, the natural language processing I mentioned just now, computer vision, robotics has been around for a very long time. All of these areas have contributed. Now, you are learning about ChatGPT. The entire world today, and I can say that entire world in the sense, let's say entire computer literate world today, think that the AI is what ChatGPT does, right? Yes and no, because that's their interaction, but that's not the only thing. There are still expert systems, there are natural language processing, computer vision, robotics. As a matter of fact, when you mentioned that you're trying to detect the buildings out of a remote sensing system, that's an expert system's job. Right now, an expert is doing today. You're trying to teach the machines to do it, right? There are a lot of areas in my area of interest, which is the healthcare technology. Lot of what radiographers or radiologists do is or computer-aided tomography or a 3D rendering of our internal body. All of it is related to vision or some kind of robotics also when you have people or machines operating on human being and performing some surgeries and things like that, right? What we are saying is that I have introduced, and up until now I have used these terms interchangeably, AI, machine learning, but machine learning is not the only AI. Machine learning is part of the AI. AI is way beyond more than that. And as a matter of fact, generative AI is not also only machine learning, that's also a part of the machine learning. So what I'm doing today, and I am not sure if I'm able to go through the entire, we probably will stop somewhere in 2025, I don't know, whenever you guys want to stop. We would continue to go into this, going tomorrow also, trying to go from a larger canvas AI to machine learning to generative AI is more narrower and narrower part of the data, or narrower and narrower part of the focus. A couple of these things I talked about. Now, terminology will change as we talked about it, right? When we say machine learning, there's always a training data. A term which we will use called features. Now, how many of you have come across the term feature? Okay. Anybody else? Okay. What do you mean by feature? Okay, that's a good enough. So anything that's of interest, in the sense that whatever the model is, whatever the problem you're trying to solve, you may say that this is an active or attribute of interest, right? A model, basically theoretical representation that you learn. We talked about Deep Blue, we talked about the model that Deep Blue use, and then you try to figure out evaluation, the optimization, or whatever is the criteria that you're using. Now, I'm not going to go into too much detail, but we will talk about these things, as I'm saying, that from a wider canvas to a more narrowing one. If we say that all learning involves data and choosing from multiple different potential answers to one answer, how does the learning happen?
It depends on how data is being represented.
Okay. Sorry, what was it?
The learning depends how the data is being represented or how it's being given to a machine.
Okay. Let's leave the machine out a little bit. How do you learn? Sorry?
We differentiate the data types when we learn.
Organized and unorganized data.
Some of you probably sit in a class and then learn there. Some of you say that, okay, I'll read the book and learn there.
Something randomly or studying something in a specific order. They want different.
Okay. How many of you learned driving? Did you learn the lesson from someone, or you just started driving and then said, okay, fine? Okay. So, basically, there's a supervised learning when someone is telling you this is the right way of doing it. Walk on the left side or drive on the left side and how to use the clutch, right? Then you have an unsupervised learning when you're saying that, okay, I'm watching people driving it, or I'm watching people walking. So you're learning by observation, right? And there's a reinforcement learning. Okay, you make a mistake, the traffic guy gives you a challan, and you say, okay, this is giving me the negative value. That's reinforcement learning, right? So it's telling you in terms of feedback, or in terms of a positive feedback or a negative feedback, right? So any kind of, and I'm going back to the same question that we've been talking, what's AI programming? The AI programming is about learning about data. You can learn by someone telling you what is what, right, wrong, left, right, yellow, black, blue. Or you can say that I will observe what people are doing and then follow that. That's unsupervised learning. Or you say that I'll do something, if I get rewarded, I will start doing this more and more. If I get punished, I will stop doing from that, right? So 3 different ways of learning basically is the supervised learning, unsupervised learning, and reinforcement learning. How did ChatGPT learn? It's an AI program. I said as an AI program, it has to do some of this or all of this. There's training data, there's features, model, evaluation. If we said that there are 3 different types of learning, so how did ChatGPT learn? Guess? Sorry? Okay. Anybody else? Who said unsupervised learning? Right. ChatGPT actually follows the unsupervised learning. That's how it started. Okay, and that's the major learning is. Alright, so we'll continue to go into that and then figure out what is unsupervised learning. Has anyone written program about any of this supervised or unsupervised learning? Which one have you done? Supervised learning. And what did you do? MNIST database and determine the numbers? No. What did you do? Sorry? Oh, logistic regression. Okay, fine. Yeah. So we'll come to those regression models because that's one way of learning it as well. All right, so let's continue to do this in the sense that these are the 3 learning ways. ChatGPT followed obviously the unsupervised learning. We'll talk about it more and we'll continue to do that. Let me introduce one more term. And I have introduced a lot of terms. Keep those in mind, right? And then see where your work is going or taking it. How many of you have heard the term called deep learning? Now, what the hell is deep learning? Any idea? What is it?
Like separate algorithms like neural networks to understand and visualize data. Like these models are based on like giving a specific output, whether it is yes or no or specific value. In deep learning, they generate images and classify based on the image and processing data.
Let me give you 3 definitions.
Kind of something like.
Let me give you 3 definitions.
Unsupervised learning, what I learned in high school.
Right. Okay. So one thing I said that let's try to be as precise as we can and the right thing. Now, let me give you 3 different examples, 3 different definitions. A couple of them are funny. Obviously, all of them are funny. When the thickness of your book goes above 3 inch, that's your deep learning, right? Okay. Anyone knows where MIT is? It's in Boston. It's a very cold place and there's a lot of snow. All their classes are connected by the underground tunnels basically. Even the hostels you can actually don't even need to come back up, you can go underground. So if your class is happening 2 levels below the earth, that's deep learning, right? Yeah, I'm kidding. All right. So let's talk about what is deep learning. So what happens basically is that the 3 things we talked about earlier, right? You have data, you have algorithms, and you have structure, right? And we will go more in detail. I'm just kind of giving you an overall view of this and a lot of the terminology that we are introducing. When do we stop?
1:45.
1:45? Okay. All right. So when you are coming up with a new structures or trying to represent how the data or information is structured, depending on what is that structure, we define the learning differently. So initially we introduced the term called the supervised, unsupervised, and reinforcement learning. If we use, and one of you did mention the neural networks, if you use the neural network to represent the data that you know, we call it as a deep learning. And there's one more condition that I'll define, is that not every neural network is necessarily a deep network. When you use the multiple layers of neural network, now don't get, if you have not heard what neural networks are, what deep learning is, that don't think that this is the last time you are hearing. I'm just giving you a very superficial view. We'll spend time, we'll look into the neural network and the deep neural network and the deep learning as well in the next few days. So if you are using neural network to represent your data or your model, and that neural network has multiple layers, then we call it as a deep learning, because it has multiple layers of learning. All my other tongue-in-cheek definitions apply. You're going multiple levels down. That's why it's called deep learning, right? What the deep learning is doing is the sense that it's trying to deal with hierarchical feature learning. So for example, you will probably find a use for it in the sense that when you're trying to recognize a pattern in an image, you can have multiple layers. One layer is trying to determine that there's an edge in the picture or the boundary. Then you might say that there's another layer which is trying to identify if there is a window or a roof or a structure on top of roof, any of that kind of thing. The layers can also use the automatic feature extraction, so that rather than saying that these are 4 edges, it will say that this is a structure that's out there. So it can also do this. You can have models working as a pipeline and call end-to-end learning, where basically they're simply saying that trying to differentiate between features, trying to combine those features, and then making sure that they can produce the final output, right? So that's what some of this going. Is deep learning relevant if you think of ChatGPT? Is ChatGPT utilizing deep learning? Yes, no, maybe? Yes. Yeah. So we'll go into that detail a little bit more. Now, if you, I'm just trying, let me try to draw some analogies here, and especially those who have done the CS in, how many of you are familiar with trees as data structures? What different kind of trees are you familiar with as data structure? Obviously, I'm not talking about banyan trees or binary tree, AVL trees. Yeah. What's the difference between them? Why so many type of trees? Sorry? Yeah, I mean, there are different ways of structuring your data depending on what your advantage is, right? So the same way or a similar way, we will see that we started with a neural network. We said if there are multiple layers, we have a deep learning or deep learning network. Just like we have multiple kind of trees, these different deep learning, deep neural networks are also divided in terms of convolutional neural network, recurrent neural network, or transformers. These are different architectures. So what is happening here is that you're taking a neural network, and the way you design your neural network layers, you call your architecture is one of them, CNN, RNN, or transformer architecture, right? So why you would choose one versus the other? In many ways, the answer remains the same. Would you use a binary search or a Fibonacci search? Or there are different ways of doing, if not same thing, very similar things. Now, depending on the problem that you're trying to solve, depending on the data that you have, you basically use one or the other of these different kind of architectures, right? Which one did the ChatGPT use? AC or DC? No? Okay, all right. We'll talk about the transformers when the time comes, but yes. And we will look into, I think, very early part tomorrow, in the sense that what changed, because we are still trying to answer the question like what changed suddenly, right? So we're going to talk about 2 or 3 research papers which basically transform the entire ChatGPT business, right? All right, let's move on to I think one of the last topics that we're probably going to cover today is the generative AI, right? So we started with the basic definition. We went all the way to AI, machine learning, and then representation, the neural networks, type of neural networks. Let's come to the generative AI. Now, I'm sure you all can define generative AI, right? Can you? What is generative AI?
So when you give real-time data to a model, it actually gives you output as real-time data. Like ChatGPT, we are giving words. We are getting words as an output. Or in some cases, we are giving words to generate some images, and we are getting image as an output. So that basically is generative.
Anybody else? I mean, clearly it can create content. It can generate text, images, audio, whatever the case may be, right? So roughly that is fine. So let's just try to figure out some basic concepts in there here. Latent space. Has anyone ever heard of this term called latent space? Okay, we're going to define this as we go along, but imagine what I have been saying. I may have repeated like 3 times already. All of it is that how well you represent the data. What do you do to choose the best option? The latent space is that a representation which will let you generate the new information. If you think about the difference between an expert system and a generative AI based system, is that an expert system will only give you the answer if someone told it what the answer is. Not necessarily so for generative AI. One of the way that the terminology that we're using is a latent space, in the sense that somehow the system has knowledge about things which it was never told, right? There's also a term that we will come across and we'll talk about, is called emergent behavior. We'll keep looking it for this as well. And we make another word here is sentient, which is very similar to the term that we use, which was singularity. Has anyone heard this term called sentient before? At least one engineer was fired from Google because he claimed that the AI has become sentient, which means that it has feelings, emotions. And he was fired from Google saying that he's hallucinating. I mean, again, but we will look into it. The step before sentient is emergent. Now, emergent is same thing as latent space. The emergent behavior is that machine behaving in a way that has not been explicitly trained for. That's called emergent behavior. And the emergent behavior comes from the latent space, in the sense that you organize the data in a way so that the machine discovers things which it was never explicitly told. See, there's nothing new here, but it's not explicitly told. We'll see the sampling and conditional generation also as part of the process, whereby we'll see that how the machines learn, and did sampling or rate of sampling or type of sampling change the learning. Okay? Nothing different. We always have been doing it that. Some professors want to sample how well you're learning on a weekly basis, quiz. Some wants to like test midterm and end term, right? It's all different ways of sampling and finding out how well the learning is happening. Machine learning is no different, right? Content generation, the conditional, again, you can think the same way, that whether you are generating text, whether you're generating images or audio or video or whatever the cases may be, right? Couple of you use the word deep fakes, right? What is deep fake? Okay, all right. I'm not asking you have you generated one or not. Now, one of the way, if you think about it, we talked about the learning. There were 3 different ways of learning, right? Does anyone remember that? Supervised, unsupervised, and reinforcement learning. Which is the best way of learning? It's a loaded question. Yeah? Yes. So, in a way, if you think about it, when I use the term best, I said it's a loaded question, but then what is the fastest way of learning? And it all depends on it, because you have to do supervised, you also have to do unsupervised. But if you want to make sure the fastest speed of learning beyond a certain point, it's the reinforcement learning, right? Now, one of the way the researchers thought is that why can't we basically have the AI itself provide the reinforcement? So, the 2 latest way the generative AI works today are using one of these 2 architectures. One is called the Generative Adversarial Networks, or GANs, and the Variational Autoencoders. The different models are using one of these 2 things. So, we will focus on the first one a little bit more than the second one, but we'll cover both of them. Literally, what is happening is that you have 2 neural networks. One is generating an answer, the second one is acting as a discriminator, i.e. it's evaluating, is it good or not good, and then providing a feedback. When you do that, you're having the learning literally exponentially increased. One is generating the answers, the other one actually is discriminating or evaluating how good or how bad they are, right? Now, some of the ways the generative AI is used, I mean, we have talked about it, in the sense that content creation, data augmentation, drug discovery, personalization, all of these different ways the generative AI is used today, right? Some of it is in a good way, some of it is in a bad way. Now, one other thing I can tell you that in US, the entire way the education is being provided is going to change in the next maybe 5-7 years. We are already changing how we actually test your learning, right? The homeworks have been stopped because there's no point asking you to write a program, because nobody's writing a program. Everybody is using Open ChatGPT to write a program. So how you're being tested is going to be changed. The essay type questions are being replaced because it goes both ways. I mean, we are already using the AI detection tools. So if you submit anything, it is going through to determine whether it's the ChatGPT generated answer or not. So all of that is happening and will continue to happen. But again, there are positives and there are negatives as well. Okay? Any questions? Yes.
Can you tell how students are tested in your institute you are teaching?
About what?
How the students are tested about their learning?
It depends on which course it is, actually.
Suppose in your course.
In my course, okay, so let me say this. I teach 3 different type of courses. Now, it's a little deviation, but if you ask that. So, I teach the 2 grad level courses. One is on computer architecture, and the other one, actually software architecture and a software design. And I teach a course on the, what is it called? Leadership and communication, basically. So it's a totally different one. So what we do here, at least in my courses, it's all evaluated by students. They work in teams, and every team member evaluate the rest of the team members. And they do it in a slightly different way. They don't evaluate the others, they evaluate themselves with respect to the others. So they would, and then again, if you think about it, if you're doing it well, then you will evaluate yourself the same way as the others think you are. So in a way, this is really, I mean, if there's anyone here from the HR world, you'll know it is a 360 evaluation, in the sense that it's like evaluating yourself vis-a-vis everybody else that you are doing it here. Primarily, the reason for it is that they're always working on a group project most of the time. So there are 2 different type of learning, actually, if you think about it. So one is the recall questions. So for the recall questions, there are always a quiz. You're not applying anything. You're simply recalling. If I ask you what was the GAN network, and you come up with the definition. That's a recall question. So the recall questions are all automated quizzes, mostly automated. So you multiple choice or something, because you're literally recalling the question. Then you have the application component when you are applying something. That is always a team project, and then most of these projects have no right or wrong answers because there are no right or wrong answers. That's when you justify what you did. And then each team member will evaluate everybody else. The way they do it is that they evaluate themselves. So you might say that I did X, Y, or Z, or I proved myself, or this was my proposal, but then it just comes back. The idea there is to determine that you're doing both. You can recall what has been told as a concept, and you can apply it. And you can apply it in a group setting, in a team setting. That's what we always focus on. In my time, the computer science was like individual action, in the sense that a programmer would sit down in a basement and then write code. No longer. You're working in a team. So we focus or emphasize a lot on teamwork, leadership, communication, and those kind of things. Doesn't matter what subject we are teaching there. So that was a side way. Any other questions? We probably can take one or two more questions. Yes.
You talked about machines becoming sentient afterwards. So does that mean they will be does that relate to gossip and greed?
The answer is yes, actually. I mean, if any of you want to do that, now I'm not saying that they have become sentient. What I'm saying is that 2 years ago, search for it, Google firing, I think the guy's name was Damore. He was fired because he thought that the machine has become sentient. This is even before the ChatGPT came on the world. Google already had the ChatGPT working, but they were pretty conservative. They didn't want to let it happen. But yes, to answer your questions, that's what being sentient means, that they get into the gossip and greed world. There was somebody else asking from this side.
Yes, sir.
Yeah.
Any criteria to add a number of neurons in a neural network show that the picture will be accurate? Is there any decision or?
So hold on to that question. Probably day 3 or day 4, when we talk about the neural network architecture, then we will see. Okay? I think your question was that how many and how to add, right?
No. How many neural networks to be added so that prediction will be result will be correct?
Right. So hold on to that question. So for day 3 or day 4, when we talk about the neural network architecture, and then we'll see that. As a matter of fact, actually, I'll say that one of the techniques that are being used today is not add, but drop. And we'll see that. Okay? So we'll come back to that question on day 3 or day 4. Okay? Always just keep in mind one thing that I tell is that how do you learn, or how do you all learn? Because if you can figure out how do you learn, you can teach the computers to learn as well, or machines to learn as well. And one other way, so let me give you an example here. Let's say you're preparing for a test or an exam. And I'm not saying that you do this, but I'm just going by my experience in this. One of the best thing is to learn sometimes is that you focus on fewer things and go more deep, rather than trying to learn a lot of things but shallow. Right? You will see the same behavior in neural network also. Their models are trained to drop neurons so that, and what has been observed is that by reducing the number of layers and neurons in a specific layer that are being utilized, it results in better learning. So we'll come to that in 3 or 4, whenever. All right, one last question, if anyone has. Okay. If not, then we'll start from here tomorrow. Okay? All right, great. Thank you.
Thank you very much. We appreciate your contribution. I'll take 2-3 more minutes time, because today being the first day, we need to know each other, and also you need to know me as a coordinator for this. In case of any difficulty, challenges, you are going to contact me. And in between, Vikas would like to display. All of you have a copy of today's agenda. Yeah, there are 2 QR codes Classroom. It's not needed. No, we stop it. Okay. So there are two courses. Hopefully you have joined. Okay, Google Classroom you need to join for the course content itself will also